We go on to question 11. Question 11 says that a trapezium has area 300 and parallel sides A and B. So let's draw this trapezium. So the parallel sides let's draw a proper trapezium. I don't know why this is. Okay, and the sides are called A and B. If the height h between the two parallel sides is increased, so the height of the parallelogram, what is the perpendicular distance between these two parallel lines? It's given the name h. Right, if the height h is increased, it's got area 300. So, okay, remember the area of a trapezium is half the sum of the parallel sides times the height. Half the sum of the parallel sides times height. And it's given that this is 300. No units are given. So we don't have to worry about that. Now the height is increased by 10%. Okay, so the height then becomes 110%, which is 11 over 10. Height goes to the new height, and the two parallel sides are decreased. You can see the lengths of both the sides A and B are decreased by 10%. So A then goes to, from 100%, it comes down to 90%, which is 9/10. Both of them. I'm having problems with this pen. Okay, A goes to 9/10 of A. Not H. All right, so you have that the sides are changed, the lengths have changed. So the new area is equal to, again, is half the sum of the parallel sides. But now the new A is 9A over 10, or 9/10 of A, and the new area of B is 9/10 of B. And the new height is 11/10 of H. So this is the new area, half the sum of the parallel sides times height. And the question is, determine this area. So we need to calculate this. If you look at this, you'll see that 9/10 comes out as a common factor. Half 9/10 And let's put the 11 tenths as well here in front. And you have A plus B. I'm taking out 9 tenths from the brackets. I'll put the 11 tenths in the front. So, so this part here, half, together with A plus B, H, all that, is 300. So this is 99, 9 times 11, over 100, times 300. Because half of A plus B times H is 300. And hundreds cancel. 99 times 3, just 297. Okay, so that's the answer to question 11. 297. Let's just see what my worked out example was. Oh, here you go, 297. Okay, I just want to check my pen. I don't know why this pen is. It's not too bad. Okay, so let's get on to question 12. So x is the square root of 6 minus square root of 6 minus, keeps going on like this. And this last dot, dot, dot says there's no end to this. It continues without stopping. So how do you calculate x? Actually, this is a standard kind of a problem. And if you've seen one, you've seen them all. The way to work it out is, well, you got a square root outside, so let's just get rid of the square root. You have x squared is equal to 6 minus. And now this square root is out, the outside square root, 6 minus. So what we've left is that part there, which is square root of 6 minus square root of 6 minus, and so on. You'll notice that this thing here is exactly the same as the original one. Okay, this is x. So this thing here is again x. So this is 6 minus x. So you have to solve for x. All right, this is a quadratic equation. X squared plus x minus 6 equals 0. You bring it to standard form. It factorizes as x plus 3 into x minus 2. There are two values for x, negative 3 and it's still giving me trouble. Negative 3 or 2. Now, x can't be negative 3 because x is a positive quantity. When you write down square root of 25, the answer is 5. It's not plus or minus 5. And always remember that. When you write down square root without any sign in front of it, you take the positive square root. So x is positive. So therefore, x is equal to 2. So that is the value for x. It's a simple problem, very simple to calculate, but you must know the strategy. So there you have it. Okay, let's go to question 13. The probability that at least 2 of the 3 children in a family are girls at least two of the three children are girls is x over 56. The probability to have a girl or a boy each equals a half. In other words, there's equal probability of getting a boy or a girl, which is quite natural. So the probability of at least two, if the family are girls, is x over 56. All right, so let's find out all the possibilities. If you look at all the possibilities, we'll start here. If there are no girls, that means all three children are boys. Right. Now, if there's one girl, now the order is important. The first one could have been a girl, or the second one could have been a girl, or the third one could have been a girl. And there are two girls. Okay, then in that case, there's only one boy. So it could have the first one could have been a boy, and the other two are girls. The second one could have been a boy, the other two are girls. The third one could have been a boy, the other two are girls. And finally, three girls. Right, so those are the only possibilities. And there are 1, 2, 3, 4, 5, 6, 7, 8. The eight possibilities altogether. And the probability that at least two of the children are girls. Okay, this is out. There's only one. No girls, no girls, no girls. I mean, one girl, one girl. But here, this is in. Two of them are girls, two of them are girls, two of them are girls. At least two means it could be three. So out of the eight possibilities, four of them satisfy the probability. So therefore, the probability is 4 out of 8. 4 times out of 8 times, you'll have a success. But now we know that 4 over 8 is equal to x over 56. So these are equivalent fractions. So you have to multiply, to get to 56, you have to multiply the denominator by 56 by 7. And the numerator you must also multiply by 7, 7 times 4. And that tells you straight away that x is equal to 28. That gives you the solution for x. Okay, let's just delete all this, and yeah, there it is. So it's the same kind of a thing. It's all written in typewritten form. So let's get on to the next question, which is question 14. Now, 4 students choose a number. Okay, so those 4 students, each one chooses a number. When each student's number is added to twice the mean of the other 3 of the numbers, the following sums are obtained. Determine the mean of the 4 numbers chosen by the students. Okay, let's just unpack this question. At the starting point, suppose the numbers are A, B, C, and D. So you say let the numbers be A, B, C, D. And they say determine the mean of the four numbers chosen. So I need to calculate A plus D. You have to calculate the sum of these four numbers. And we give it a name S. You'll see just now why, because it simplifies calculations a lot. And the question is, what is the mean? Mean is average. So you got four numbers, and the sum is four. So you need to calculate what is S divided by four. That'll give you the average. Now, they tell you that when each student's number, let's take the student here, when his number is added to twice the mean of the other three numbers. In other words, I'm going to add the remaining numbers, which is B plus C plus D. I'm not going to put that down like that. I'm going to write this thing as S minus A. Instead of writing all three symbols, we just put S minus A. And it's the mean of that. So it's the average of the mean of the other three numbers. So, and that is equal to one of them. We'll just call it 42. And likewise, if you take B and you take the mean of the other three, then you will have S minus B. And the second number, 54. Or you take C plus twice the mean of the other three. So you have to remove C from there and take the mean of that. That's twice the mean. That's the third number. And the fourth number, in the same way, is 78. Right. Now you might think that this is so many, four unknowns. Now we have to put in another unknown S. So there are five unknowns, we've got four equations, right? But because of the symmetry of this, you can exploit this because we know S is the sum of the whole four, right? So let's add right throughout. Add on both sides. With A plus B plus C plus D, we name that S plus. Sorry, this pen of mine is really giving me trouble. And so it's those first four gives you S. Now here you got 2/3 right throughout. I'm going to add all of them. 2/3. And then if you take the 2/3 out, you have S minus A plus S minus B plus S minus C plus S minus D, which makes it 4S. And then you get minus A minus B minus C minus D, which is minus S. It is minus A plus B plus C plus D. Right? Minus A minus B minus. And that is equal to be adding on both sides. When you add the other side, you'll get 240. say 96, 162, 240. So here you only got one unknown now. This is beautiful. So this is 2/3 S plus 4s minus S is 3s. So 2/3 of 3s is 2s. So S plus 2s is 3s. So S is equal to 80. Now, that's the sum of the four numbers. Remember, the question was not to find S, but to find S over 4, the mean of the whole four numbers. So the answer is S over 4. It's 80 over 4, which is 20. So that's the mean of the remaining four numbers. Okay, so we can cancel this and check to see. I always expose this solution. Now you see here, I made it look very complicated here. I didn't use S minus. You see here, I could have put in place of B plus C plus D plus D, I could have make this S minus A. Now you got all these four unknowns, four equations, and now at the end, I'm calling it X. I call it S. And when you add it up all this, you come back to the same thing. Okay. Let's get on to the next problem. You come back to the same answer, 20, by the way. We go on to question 15. The vase-like shape in the sketch is formed by 6 circular arcs. So you can see the 6 arcs, they're all arcs of circles. So you can see this arc, you can see this arc, but they got a dot here which says this arc starts from B and finishes off at C. There's another one here, there's another one here. Put all these together, you get a lovely vase like this. Each of which is a quarter of a circumference of a circle of radius h, of radius 6. So each of them, like for instance, this one here, is a quarter of a circumference. So it looks something like this. Okay, let's just draw the quarter of the circumference. I want to take so you see, like for instance, this arc here is the same as this arc here, but this is a quarter of a circumference, which means that the angle in between is 90 degrees. See? So what it means that this is the center of the circle. So if I complete the diameters, like that, then you have all 90 degrees here. So these are all arcs which are placed here. Like this one here is there. Okay. These are all 90 degrees now. All right. Now I just want to see here. Which is a quarter of the circumference of the circle of radius 6. So the radius of the circle is 6. So there is 6 there. Okay? And they all join together. The question is, what is the area of the vase? What I'm going to do here is to find the area, is to join A, B, and C. Sorry, the spin is really messing me up. And join F, E, and D. And then I'll join this as well. Okay. Now, if I join this, what happens is that you've got two equal squares here. They look like squares, but you must, to understand why, let's have a look at the bottom one. The bottom one, I say that this is a square. The reason is, if you take what I just told you now, when I join the diagonals of this quadrilateral, right? It turns out that the diagonals are equal, and they also bisect each other. So it means that all these are equal. So you can see if I take my compass point and place it here, and take this as a radius, you can see it must go through B, E, C, and D, because all these are equal in length. So this is quarter circle. Now, I'm going to show you something. You see, there are two pieces which are outside these squares. Now, suppose I cut these outside ones and place it inside here. They are exactly the same. Because this is also a quarter circle. So they are the same. And if you take this and place it inside here and patch it up exactly, these two will be the same. And you can do the same thing here. Cut this thing out and patch it here. Right? So the area that you're looking for, the area of this vase, right, watch. It's all this white part here inside. Let me get my arrow. All the white part inside, together with these two outside here. right? That'll give you the bars. All the outside white and the inside of the square together with these bars. That is the area you're looking for. Now, we've taken those two areas and put them inside here like this. And now you have the same white part. Oh yes, there's also this part here as well. We also have this part, this bottom part. We can cut this bottom part out and fit it exactly inside here. Right, so you'll see that the square has got the horizontal lines and the other one has got the vertical lines. So the area of the vase is actually equal to the area of the rectangle AFDC. And this is the rectangle. I just cut out those pieces and put them in, and you create the rectangle, right? This goes inside the rectangle. This outside part goes inside the rectangle, and this outside part goes inside the rectangle. And that way you're making up, touching the rectangle using parts of the vase. So it's the same area. Now, the area of the rectangle, let's call this, I'm going to just remove these now. And just retain only the rectangle. Oh God, this is really a pain here. Sorry, I'll have to do something about this pen. Now, what I want to say is the rectangle is really made up of two squares. So if we call this area X, we call this length X, yeah? These are squares, as we saw. But they're equal squares, you see, they're identical squares because they all got the same sides. See, the side of this square here is the same as the side of that square. So they're identical squares. So if this is X, this is also X. So the area of the rectangle is equal to X times 2X because the breadth is X and the length is 2X. That's 2X squared. All right. So, but we do know the radius is 6, right? The radius is 6. And this is your X here now. So if you call that, well, the one that I just drew now, this is X. It's just, it's the same piece here, like this. That's what I've got here. Now you can see that these are 6, this is 6, and we needed to calculate x, and Pythagoras kicks in. So for x squared is equal to 2 into 6 squared plus 6 squared. Because this x is the hypotenuse of the small right angled triangle. And that is 72 plus 72 is 1 times 2 is 144. So the area of the vase is 144. It's a good example of where you cut out and patch so that the area that you're looking for is the area of something else that you can calculate. That's what I've done. Just cut and patch, cut and patch. Okay, so let's see what I've done my earlier. Okay, you still get 144. All right, so I'll just expose that so you can check that out and get a better understanding of the problem. So question 16 says, contestants in a singing competition must each select 2 songs from a list of 20 to perform. Okay, so they've got 20 different songs and they must choose 2 songs from there. The interesting question is, how many ways can you choose 2 songs? If you got 20. Right? We've seen this at other sessions like this. And the master formula for that is the number of ways of selecting two objects, could be anything, need not be songs, from n objects is n into n minus 1 over 2. If you want to understand where that came from, suppose you had 4 objects. Say n equals 4. Right. Let's call them. Let's call the objects 1, 2, 3, 4. I want to select 2 objects from there. So I can do 1, 1, 2, then 1, 3, all those which have got 1 in it, and 1, 4. Those are the only 3 cases where the 1 inside. So now I'm going to avoid that 1. 2, I'll take all those which have got 2 in it. I don't have to put a 1 because we've already counted that. So you get 2, 3, 2, 4. Right. Then you say, okay, let's take 3. You can't put 3, 1 because 3, 1 is already there. You can't put 3, 2. Right? But you can have 3, 4. So these are the only ones. You will see the number of ways of selecting 2 objects equals, actually, I'm not going to say equals. I can count it 6, but it's actually equal to 1 at the bottom plus 2, that's the second row, and 3, the third row. So when you try to construct this thing, no matter how large n is, you can do it like this, and this is the pattern that will emerge. So if you've got n objects, so here you've got 20 uh, songs to choose from. So it will be 1 plus 2 plus 3 up to when n was 4, you landed up with 3. So with 20, you end up with 19. All right, so the number of ways in which you can choose two songs. You see, I don't come to the question. I should have done that. What is the least number of contestants that need to enter the competition to ensure that at least two contestants make the same selection? What it means is that you can have a number of people who are selecting two songs. And is it possible that no two people select exactly the same pair? Right? Now, what we have done is we counted the total number of ways in which you can select two. And this is a well-known formula. It's 19 times 20 over 2. 2 goes into 20. 10 times 19 times 10 is 190. Okay, so there are 190 different ways of selecting two songs. So if you've got 190 contestants, it's quite possible that no two that you give each of them one pair, right? And one pair of songs. And altogether, once you come to 190, then you've exhausted all the possible pairs, right? So if there were 191 people, for instance, then you can be sure that that person will have to be given one of the other pairs, right? So what is the least number of contestants that need to enter the competition to be sure that at least two contestants make the same selection? So 190, there will be make no selections. If there were 190 contestants, each one of them can make different selections. So the least number is, as soon as you hit 191, then that last person will have to choose one which has already been chosen. Right. So to be sure that at least two contestants make the same selection, 191 will ensure that two contestants will make the same selection, and it's the smallest number. Right? Because at 190, you can be sure that everyone can be given a different pair of selections. Okay, so let's just see whether this was. Oh, there it is. It is 191. But he got onto the formula straight away. Not E, I got onto the formula. Well, let's just clear all the drawings and problem 16. Problem 18. Oh, yes, I haven't done 17. Okay, so here's 17.